Hello, this is a video to demonstrate the use of an oscilloscope and current clamp to test an electric fuel pump. The test will allow you to test whether or not the pump has bad commutators and if it is actually pumping. You can also check for impending failure, giving you the ability to catch the fault before it becomes a breakdown. You'll need the following: an oscilloscope, a low amp current clamp, jumper cables for the fuel pump fuse, or jumper cables for the relay. In this case we're going to use the fuel pump fuse, and a secure table for your equipment, and obviously laptop to view the screen on. Firstly, you will need to connect your current clamp into your scope. Firstly, you will need to connect the current clamp into the scope on channel A. After you've connected the current clamp, you need to set the voltage scale according to your current clamp's output. The low amp clamp we are using needs to be set to the 20 amp range, and as you can see, this gives an output of 100 millivolts per amp. Now, depending on your pressure, a normal in-tank fuel pump will pull no more than 8 amps. So you need to set the voltage scale to 1 volt DC to start with, as we have here, 1 volt DC on channel A. You may need to alter this to 500 millivolts DC if the pump is not pulling as many amps and the waveform is too small on the screen. Then set your time base to 5 milliseconds per division, and again you may need to alter this slightly for a faster or slower pump. Now we need to zero the current clamp. On this current clamp you have a 0 button. You push the 0 button and the trace will go to 0 on the screen. The current clamp also has an arrow with a positive symbol inside the jaws. Make sure this arrow is pointing away from the battery positive. If you connect this the wrong way round, the oscilloscope trace will be inverted. Now you need to locate the car's fuel pump relay or fuse. In this case we're going to use the fuel pump fuse and insert the jumper cable. This is a fuse jumper cable and just allows for easy connection of the current clamp. Now, using the fuse box legend, we have found that fuse number 30 is the fuel pump fuse, so I'll just go ahead and insert the jumper cable, and now we can easily connect our current clamp, making sure it's fully closed and not trapping the wire, and now we can measure the fuel pump current. Now you need to start the scope recording and switch on the ignition. You can see the waveform of the pump. This is the current draw of the pump. It has a series of humps and troughs. The humps are the current draw for each commutator bar in the motor. Most fuel pumps have either 6, 8 or 12 commutators. This one has 12, and they should all have an equal current draw. If one or more of the humps is lower and this pattern repeats itself, then one or some of the commutators is bad or going bad. You can see here we're missing a hump, we have a broken hump here, and it repeats itself. That means one of the commutators in this fuel pump motor is dirty or going bad. You can even show this to a customer to prove your diagnosis, or if the customer is going on a long trip, then you can show them that they might have a fuel pump problem before much longer, and it would be better to prevent a possible breakdown now while the car is already in the shop. A fuel pump with bad commutators can cause drivability problems and poor starting. Left unattended, it will cause a non-start. If you require any further information, then please feel free to visit the Pico Auto website. Thank you.